In this section, we're going to talk about the derivatives of products and quotients. So what we mean by a product is a function that's made up of the multiplication of two or more things. Say, for instance, a y is equal to an f of x multiplied times s. Those are two separate functions multiplied together. We might hope that taking the derivative of a product would mean just taking the derivative of each of the factors in the product. But it turns out that's not the case. So y prime would not be equal to f prime times s prime. That just doesn't work. Instead, we have what's referred to as the product rule. And the product rule says you would do f times s prime plus s times f prime. I like to think of it as the first part times the second. And the product rule tells us we do the first times the derivative of the second plus the second times the derivative of the first. But that's both the notation way of writing it and a more perhaps familiar way we could think of it as we go through using the product rule. Let's use the product rule on this one here. 2 to the x squared, then in parentheses next to it, 3x to the fourth minus 2. Now we could actually use other means of finding the derivative here, not necessarily using the product rule, but this is a good place to start just to illustrate how it could be used. So we have here the first and the second. So again, f prime of x, we start off by writing the first 2x squared times the derivative of the second. The derivative of the second being the derivative of 3x to the fourth minus 2. What is the derivative of that part, 3x to the fourth minus 2? That would be 12x to the third. That's first times derivative of the second, plus the second times the derivative of the first. So we go plus 3x to the fourth minus 2 times the derivative of the first. That would be the derivative of 2x squared. What is the derivative of 2x squared? That would be 4x. So that right there represents the derivative via the product rule. Now, what I will do is go ahead and clean things up a little bit here. So f prime of x, we'll start off by multiplying the 2x squared and 12x to the third to get 24x to the fifth. Distributing the 4x, we would have 12x to the fifth minus 8x. So f prime of x would be equal to 36x to the fifth minus 8x. Now let's look at this next one here. It says use the product rule to find f prime of x. So if you want to give this a try on your own, you may want to pause the video here. See if you can use the product rule to find the derivative of this one using first and second. So by the product rule, we would do first 2x minus 9 times the derivative of the second, which is 2x. That's coming from x squared plus 6 and its derivative, plus the second x squared plus 6 times the derivative of the first. From 2x minus 9, we have the derivative is just 2. Okay, so that's what the product rule tells us it's going to look like here. Let's go ahead and distribute into the parentheses. So we're going to have f prime of x is equal to 4x squared minus 18x plus 2x squared plus 12. Combine like terms there. It would be 6x squared minus 18x plus 12. Let's go through some more examples, starting with our f of x is equal to 2x to the third e to the x. So here we got to break it down into the first and the second. The first part is the 2x to the third, and the second part will be the e to the x. So when we do f prime of x, we start with first, 2x to the third, times the derivative of the second. So derivative of the second is derivative of e to the x, which is e to the x, plus the second, which is e to the x, times the derivative of the first, which would be 6x squared. So we could write f prime of x is equal to 2x to the third e to the x plus 6x squared e to the x. And I'm frankly pretty okay with that way of writing it, but sometimes the homework will have you go through and find the greatest common factor and factor it out. And the GCF here would be 2x squared e to the x. Is what they all have in common. So we could write this as 2x squared e to the x, parentheses, x plus 3. 2 being the biggest number that divides in both 2 and 6, and x squared being the largest factor in common from x to the third and x squared, and also e to the x is in common with both as well. Let's look at this one here. It goes 6x to the fourth ln x. The first would be the 6x to the fourth, and the second would be ln x. So f prime of x, we start with the first by the product rule. First, 6x to the fourth times derivative of the second. And what is the derivative of the second here? For ln x, the derivative is 1 over x. First times derivative of the second plus the second, ln x, times the derivative of the first. That would be 24x to the third. So f prime of x, let's write it here like this. 6x to the fourth over x plus 24x to the third ln x, which we could simplify by crossing out x from top and bottom. We would have 6x to the third plus 24x to the third ln x. Here we have f of x is equal to, in parentheses, 1 plus x minus x squared, close parentheses, then e to the x. So here we got to point out the first, which will be all the stuff in parentheses. The next to that, the second, would be e to the x. So f prime of x, we start with first, 1 plus x minus x squared, derivative times derivative of the second. Derivative of the second is still e to the x, plus the second, e to the x, times derivative of the first. Derivative of 1 plus x minus x squared would be 1 minus 2x. Now I'm going to take this opportunity before I go too far to take this e to the x as a common factor and factor it out. So we could write it as e to the x, parentheses, 1 plus x minus x squared plus 1 minus 2x. Combining like terms, this would equal to e to the x, parentheses, 2 minus x squared. Here we have 9x to the 1/3 power, and then parentheses, x to the third plus 5. So we break it down again into the first and the second parts of the factors. So we start off with f prime of x. We got to do the first times the derivative of the second. So we'd have 9x to the 1/3, derivative of the second is 3x squared. So then we pay plus the second, which is x to the third plus 5, times the derivative of the first. And this is where things get interesting. To take the derivative of the first, that's the 9x to the 1/3 power. It's going to be 9 times 1/3 x raised to the negative 2/3 power. So that's again coming from the fact that I had to bring the 1/3 out to multiply times the 9 and also subtract 1 away from the exponent. Let's do some cleanup here on the numbers that we have. F prime of x will equal to, starting with the 9 and the 3 multiplied to 27x. Something else you got to look for is the fact that these powers will add together. 1/3 plus the 2 is 7/3. So that would be to the 7/3 power. Plus, and then I'm going to leave this as x to the 3rd plus 5 in parentheses. Parentheses 3x to the negative 2/3 power. So I'm not actually going to do a whole lot of extra stuff to this one to finish it up. I will go ahead and write this as 27 cube root x to the 7 plus 3 x to the 3rd plus 5 over x to the 2/3 power. I'm just doing that so I can move the negative exponent part down underneath. Everything else goes on top. Or we could write that as 27 cube root x to the 7 plus 3 parentheses x to the 3rd plus 5 all over cube root x squared.